Hi, Math Dragons. It's your teacher, Mrs. Morgan, back for a quick edition of Multiplying Decimals. So as we all know, the struggle has been real. Multiplying decimals is challenging. I've taken a test question here. Actually, this is off the mini quiz that you took probably about a week ago. And I was going to break down how this works. One thing I know is if you're struggling with multiplying multi-digit numbers, multiplying decimals is going to be also challenging. But I'm going to walk you through all the steps. I'm not even going to write out all the notes. I'm going to show you how the steps work. We don't want to multiply by decimals. We want to get them to look like whole numbers. So I'm going to start with 39 3/10 times 5 26/100. Remember, when you multiply and divide, decimals slide. So you just want everybody lined up to the edge. You do not need to stack your decimal points. Our very next step is going to be to find out what power of 10 I need to multiply each of these by to temporarily remove the decimal. This one I can multiply by 10. This one I can multiply by 100. Now I'm dealing with a situation where it's 393 and 526. I'm going to multiply these in a traditional algorithmic manner. If we have 393 times 526, sorry about the typo there, I'm going to accumulate several place values. And that's the first thing we need to talk about, the place values. If you only get one line of numbers, you're not doing multi-digit multiplication correctly. In this row, we're going to get the partial products for everything that 6 multiplies by. And 6 is currently in the ones place. So this is going to be the partial products for the ones place. Then we're going to move on to the 2, which isn't in the 2's place. It's in the 10's place. So then we're going to get a whole row of partial products in the 10's place. Partial product means a portion of the final product. Product means the answer to a multiplication problem. So when you have multi-digit multiplication, you are chopping it up into smaller parts to make it easier to solve. And then we're going to have a third row of partial products concerning the hundreds place. Now, to look at this from another angle, I have this problem here, is what we're working on. And I can decompose this number into the hundreds, tens, and ones place. If I were to use the distributive property and the area model, I can show you that I'm going to multiply all of this by the hundreds place, all of this by the tens place, and all of this by the ones place. I want to prove to you that these rows here become the same rows that exist in the area model that you're familiar with. Hopefully, if I do it right, it'll be a true story. Okay, so I'm going to go through. I'm going to do 6 times 3 is 18. Put down my 8. Carry my 1. 6 times 9 is 54. Plus 1 is 55. Put down my 5. Carry my 5. 6 times 3 is 18. 18 plus 5 is 19, 20, 21, 22, 23. 23. Now, I'm in the tens place. I'm all done with the ones place. I need to put a placeholder. That's what's happening here. Placeholder. I like to cross out these things that I carried so I don't mess them up. Do not work with the 6 again. Technically, you're done with the 6. You are now working with the 2, which is really a 20. It's a 20 because you already put something in the ones place. 2 times 3 is 6. 2 times 9 is 18. Put down your 8. Carry your 1. 2 times 3 is 6 plus 1 is 7. Excellent. I have 2 placeholders because I'm moving to the hundreds place. Placeholder, placeholder, you are finished with the 2. 5 times 3 is 15. Put down the 5, carry the 1. 5 times 9 is 45, plus 1 is 46. Put down the 6, carry the 4. 5 times 3 is 15. 15 plus 4 is 19. Excellent. So now you finished the 5. So you've done 6 times 393, 20 times 393, and 500 times 393. That is all here. You have done 6 times 393, 20 times 393, and 500 times 393. What are you going to do with all these partial products? What's the next step? You have all the pieces. We have to put them together. This is when you take all your partial products and you add. 8 plus 0 and 0 is 8. 5 and 6 is 11. Carry the 1. See, 8, 9, 10, 11, 12. 12 and 5, 17. 13, 14, 15, 16. 1 and 9, 10. Boom. Okay, so this is my raw answer. I don't have a decimal place there yet. Now remember, I did all this work over here to put the decimal, to take the decimal out. So I multiplied by 10, 1, 2, 3 times, really. So I'm going to have to divide by 10 3 times. The decimal naturally lives here, but you're going to go 1, 2, 3 movements in because you are dividing by 1,000. Because total here, you multiply by 1,000 here. You can shortcut this by seeing 1, 2, 3. You did 3 powers of 10, 1, 2, 3, 3 powers of 10. This is 10 to the third power. This is also 10 to the third power. Your final answer is 206 and 718 thousandths. Happy answer. Now back to proving that the partial products work in the area model. 593 times 500. You know, I can even prove it on the calculator. 593 times 500. Or 393. 393 times 500 is 196500. Is that in my original? Sure is. There it is. There it is. It lives here. It's the 196,500 part of my model. Let me zoom out so you can see that the area model is proving the algorithm. This line here is this part of the rectangle here. 393 times 20 is this line here. 7,860. And I'm just going to do the math again to prove to you that it is. Sure is. So that is 7,860. And then 393 times 6, I'll do the math real quick again for you here. 54, 55, 18, 19, 20, 21, 22, 23, 23, 58. Partial product, partial product, partial product. What do you do with all of them? Of course, you add them. So you would take all of them, you would add them nicely. This is not pretty at this point. You'd get all their place values lined up correctly. But all these partial products are all identical to these partial products. If I add it all up, 8, 11, 1, let's see, 11, 12, 17, carry the 1, 13, 14, 15, 16. Yep. Same thing. Lights went out. Okay. So hopefully you caught that the area model shows all the partial products. The multiplication algorithm, which is just the formulaic way to handle it, shows all the partial products. What is mandatory for you to know is that multi-digit multiplication requires partial products. So step 1 is being able to multiply more than one digit at a time. You saw that I could multiply quite quickly. That's because I have my standard facts memorized. 1 through 12, I have memorized. It is imperative that you also memorize 1 through 12. This one is directly off a quiz you did. Here was my original answer key, which is not is detail-oriented, but I still had to show all my partial products, but this time I showed you all my partial products and how the decimal point moved. I hope this mini lesson helps. I'll do another one on decimals in the near future. Thank you.